Hello 108 students, welcome to chapter 2. Mr. McHugh here with you. We're going to deal with linear equations and inequalities and applications in chapter 2. So we're going to jumpstart our work here today on our talking class note videos, and we're going to go ahead and go work on section 2.1 linear equations with one variable, and this section we'll go ahead and take care of page 1. So I just want to make a general statement here. If you had 025, the content of that course was covered in chapters 1 through 7. We are basically going to, repeat those chapters here to be the first half of this 108 course, and think of we're going to go faster and a little more in depth as we go through. So it's not 100% the exact same thing, but most of it. So with that said, let's go ahead and get started here. And linear equations here, I'm looking at objective number 1, and how do you know this is a linear equation? It's very simple. Look at the exponents. Look at the variable. We only have one here, and it happens to have an exponent of, we don't see any. Of course, we know that we assume it to be 1, and that is what makes it a linear equation. Okay, so how do we solve or isolate that value of x to find out what would make it true? We basically are going to use our properties of equality from objective number 2, and you know that you can add, subtract, multiply, or divide on both sides of the equation by the same amount of terms, and we're going to show lots of examples of this. Okay, so this in my class, I like to think of this as a toolbox. I'm going to help you with the reasoning as to know what toolbox to pick here. Okay. As an example, when I put this plus sign in a circle, it looks like a Phillips screwdriver. Think of it as the additional property. So when do you use that? Well, think of your goal as always to isolate the variable. How about this one? This looks like a flathead screwdriver. That would be the subtraction property of equality. This is a star, and they make star screwdrivers, and you're going to think of multiplication. And this one is not really a real screwdriver, but it's division, simple, and think of him as the closer. We use him a lot to do the last step. Think of your baseball pitchers. They're going to come in and divide, and we're going to do it here up in this example. So think of him as the closer. So here's your toolbox. You're putting these basic properties these skills you're going to use to isolate your variable. Now go back up here and look at this example. 5x plus 2 equals 17. What can you do to isolate the 5x term? Okay, guess what? Anything else that's on the same side as the x, take it over to the other side. So you have to ask yourself, what's the opposite of plus 2? Answer is minus 2, so you minus 2 on both sides, and let's write the result. You bring down 5x. This would be what? 0. And of course, 17 minus 2 is 15. So you have 5x equals 15. Now, what is going on between the 5 and x? This is a term, and the answer is what, class? Hopefully you're answering for me, and you're saying multiplication. You must know that. That's part of I call the secret decoder ring. Anytime you see a number and a variable, it's multiplication. Mathematicians got lazy and they didn't want to write the multiplication all the time. So the question is, what can we do to isolate the x term? Well, we got 5 times x. How do you undo multiplication? Guess what the answer is? Closer, division. So if I divided both sides by 5, remember you must always maintain balance. Whatever you do to one side of the equation, you must do the other side. Well, why divide by 5? Well, because anything divided by itself, 5 divided by 5 is equal to 1. 1 times x equals 15 divided by 5, and you have 3. Final answer, x equals 3. Solution set, you put the brackets, you put the 3 in, and you got it. Okay, so we're cruising here, and these examples here, just to illustrate here that let's say you and a friend are going to Sonic, and I have $3 in one part of my wallet and $2 in the back, and my friend, aka my wife, she has a $5 bill, and we're going Dutch. Okay, bear with me, my silly example. We turn around and buy the $2 mini limeberry cream slush. I think that's what they're going for now. I go into my wallet, I take out $2 to pay for it. She hands the cashier a $5 bill to take out her $2. Will we both have the same amount of money in our wallets? The answer is yes, because 3 equals 3. And that's what's going on with these properties of equality. Okay, so you could study those a little bit more. Now, let's work here real quick on example 1. Let's turn around and ask ourselves this. Here's the equation. 4x minus 2x minus 5 equals 4 plus 6x plus 3. Okay, holy moly, lots going on here. What can you do to simplify these? I think of mathematics and algebra here as working down the funnel. What can you do each step that you show that works it down, makes it easier and easier to understand what's going on? And so first thing you want to think about is on each side of the equation, can you combine like terms? That's what my CLT stands for. 4x minus 2x, are they like terms? Here's the requirement. Do you have the same base variable? Yes. Do you have the same exponents? Yes. They are like terms. Take the coefficients 4 and the 2, subtract them. 4 minus 2, result is 2x. Minus 5, look strictly on the left hand side, nothing there, bring it down. Over here, 4 and a 3, can you combine them? You betcha. There's the 7, you bring down the 6x. Okay, now every time you've simplified the equation, you combine like terms, you have an easier version of the problem to look at. You go, I got to isolate the x. There's a 2x on the left hand term and a 6x on the right hand term. What do we got to do to combine like terms? Now for a lot of students this drives you crazy, but all you got to do is remember, look at the 2x and look at the 6x. I strongly recommend, now you could do either side, but I recommend you pick the smaller of the two terms, which happens to be 2x, and move, M-O-V-E, move it to the other side by taking the opposite. Opposite of plus is a minus 2x. So you're doing that on both sides of the equation. Minus 2x. Now I like to draw the lines. I now like to add my columns up. Combine them. 2x minus 2x is a 0. Bring down to minus 5. Bring down to 7. 6x minus 2x is 4x. Notice how the equation is getting easier to look at. Now over here, where's your x term at? It's on the right hand side. No big deal. Leave it there. What's also on the right hand side? A constant 7 plus 7. What can we do to move the 7 over? Take the opposite. So we subtract minus 7 on both sides of the equation. Thus we are using the subtraction property of equality. Okay, you went in your toolbox, you took 7 away on both sides. What's the result? Minus 5 minus 7. Be careful, watch your signs. It's minus 12. If you're not sure, come over here and do it long ways. This is where a lot of people, what do you do with subtraction? Convert to addition. What do you do with the second number? Change the sign. Here's where everybody gets messed up. The assumed sign of the 7 is a positive. Change it to a negative. Negative 5 plus negative 7. Hey, I owe my wife $5. I borrow another $7 from her. You bet she wants $12 back when I see her, when I get paid. I don't know. I think I get paid on the 20th. Oh, I get paid on the 10th. Yeah. She's going to want her money here next Sunday. Okay, I got to make sure I pay her up. Okay, so look. Minus 12 equals, this adds up to a 0. 7 minus 7 is 0, 4x. So negative 12 equals 4x. What's your closer step? What do you do to isolate the x term? The x out from the x term. You got multiplication. Divide both sides by 4. Bingo. 12 divided by 4 is 3 equals x. And ooh, look what I almost did. Watch the minus sign. Okay, Mr. McHugh here for now. We're going to wrap up page 1, and I'll see you on page 2.